Right, so we are going to be looking at method 2 to the example that we have. So we would take note of certain aspects before we jump into our method 2. So we have to take note of the number of years, which is 5 years, the number of periods, 12, and the rate, interest rate, that is, and that is 0.10, which is equivalent to 10%. So note, with method 2, unlike method 1, where we had to shift everything to the final period, then find the difference between the values. In method 2, we are saying that when the first payment is made towards reducing the value of the loan, we consider that. That is to say, the loan that was given was 10,000. Now at time T1, so our T1 is 3 months. So that is something that we have to be aware of. So this is 3 months. So with the 3 months over here, we know that that loan would have accumulated some interest in the 3 months. So we are going to get the value of that particular loan in 3 months, then subtract the payment that was made. So that is basically what we are talking about. So now, in order for us to get what the value of the loan is in 3 months, we are going to find LV1. So let that represent the first payment. So the 1 is for the first payment that was made. So we do have cases where we have multiple payments actually, but in this case, we just have one payment, so we'll stick to that. So let's call this one LV1. That is to say the loan, the value of the loan at the first payment in order to reduce the loan. So we need to find the value of the loan at that particular period. So LV1 will be given by the loan itself, 10,000 times 1 plus 0.10 divided by 12. So the 0.010 is the rate, and the 12 are the periods that we have in a year, and also the 3 would be the period in which it takes to clear, not clear, but in order for the payment to come through. Yep, I think that is how I would put it. So with that, we know that we would need to simplify what's inside the parenthesis. So inside the parenthesis, this expressed as a fraction would be 121 divided by 120 raised to the power 3. So I would encourage you to deal with what's inside the parenthesis first so that you avoid making unnecessary mistakes. After that, then you multiply or you raise it to the power 3. Then multiply with the 10,000 so that you get the answer to be $10,252.09. This means that this is the value of the loan after 3 months. So now that we have obtained the value of the loan in 3 months, we see and know that in the 3 months, a payment came through that was meant to clear the value of the loan. So that happens, implying that the value of the loan at that particular point, 3 months, is going to be LV1 minus P1. P1 is the payment, and LV1 is the value of the loan after 3 months. So we find the difference between the two times the interest that will be accrued from 3 months up until the end of the periods where the whole loan is due. So we know that the period here, since we're calculating from the 3 months, so we are going to subtract 3 months from the time the loan is due. Substituting for LV1 that we obtained earlier on, we are going to have the $10,252.09. Then the payment was 3,000 times then that which would generate the interest compounded monthly. So we would have that bit over there, and of course substituting for the n and for the I, which is 12, we are going to get that. And I would encourage you once again to deal with what's inside the parentheses first. So dealing with the the LV1 minus P1, the 3000, then multiplying with what you would get inside the second set of parentheses raised to the power 60 minus 3, which is basically 57. Then with that, then we are going to end up having something of this nature. So $7,252.09. And then we have that bit, which is the second parenthesis, 121 divided by 120 raised to the power 56. So I'm doing this because I want to keep my values exact. So the more exact your values are, the better your answer comes out. So it wouldn't be different from somebody who used a software to solve the problem, because you would know that in some exams, in some instances, some values are calculated using some software which are exact. So each and every calculation is exact. But if you start rounding up your answers prematurely, it means that even your final answer would end up being compromised and becoming slightly different, if not much more different from the one that is expected of you. So you wouldn't want that to pop up in the exam. So try to keep your values as exact as possible. Right, so simplifying further, we are going to end up having $11,638.54. Now take note, I rounded prematurely over here, and my answer is slightly different from method 1. In method 1, we had 53 cents. However, it is worth noting that in many instances, what does happen is that the answer becomes totally different. Yes, some may say, of course, if we round our answer up to some, say, 2 or 3 significant figures, the answers will still be the same, but at times that wouldn't really work. So it's important to keep your answers as exact as possible. Then this will be how we use method 2 to solve such questions.